we have to go over some basic stuff that's going to lead us up to the calculations involved in the mole concept. So the first two concepts here are pretty straightforward. The first thing we need to know how to do is calculate the mass of a compound. So prior to now, we could find the mass of an individual element by just going to the periodic table. For example, if you find a periodic table square like sulfur, the mass of a single sulfur atom is 32.07 AMU. Okay, so atoms, the masses are on the periodic table. But what if we put the atoms together into a molecule, like let's say SO3, for example? How do we find the mass of the whole molecule? Well, it's easy. You just add up all the individual parts that make up the molecule. So in the case of SO3, there is one sulfur atom, but this 3 tells us there are 3 oxygen atoms. So we find the mass of sulfur, we find the mass of oxygen, and then we figure out how many we have of each to get the total mass. So you can see there, 32.06 for the mass of sulfur, plus I put 16 3 times because there are 3 oxygens. And if you add all those up, the total mass of that compound is 80.06. The unit is at this point AMU because that's all we've talked about. That's just an atomic mass unit, meaning protons plus neutrons. Now, one thing that is important here, because we're going to need consistency moving through the rest of the year, whenever you take a mass from the periodic table, one of these decimal numbers, we are always going to record that value and use that value in our calculations to 2 decimal places, meaning 2 places past the decimal point. So sulfur here is already written to 2 decimal places, 32.07. Okay, so you would record it exactly as that. The periodic table I used was 0.06, which is why it shows different here. Oxygen, again, even though it's 16, you need to record it to 2 decimal places, 16.00. All right, so moving forward, anytime you get a mass off the periodic table, go to 2 decimal places. So this can be for something as simple as SO3 or H2O, but it can also be a little more complex. Like, for example, magnesium nitrate. Magnesium nitrate has this nitrate polyatomic ion, and then we have the subscript outside. So how do we count the atoms in this particular molecule? Well, remember that after each element, there is a subscript, whether it is a 1 and not written or a written subscript. So in this case, magnesium does not have anything written after it. So that tells us we only have 1 magnesium. Within this polyatomic ion, there is 1 nitrogen, again, because there's a subscript 1 here, and 3 oxygens. So 1 nitrogen and 3 oxygens within that polyatomic ion. But this 2 tells me that we have 2 entire nitrate groups. So if I were to actually write this out, what we have here is 2 of these NO3 groups, okay? And you can see there then that we have 1, 2 nitrogens, and 3 plus 3 gives us 6 oxygens. Another way to look at this, rather than just picturing 2 entire nitrate groups, is just like in math, when you have things inside parentheses and then a number outside the parentheses, if you're doing multiplication, you distribute the multiplication through the entire thing that's inside the parentheses. So if we think of this as being a 1 here and a 3, if we take the 2 times the 1, that gives us our 2 nitrogen. And if we take the 2 times the 3, That gives us our 6 oxygen. Then we just do the math like we did before. So we're going to find the mass of magnesium, nitrogen, and oxygen from the periodic table. Here's our squares. There's our masses. And now we're going to add them up. So 1 magnesium, there's 2 nitrogens. So we're going to take 2 times the mass of nitrogen, and then 6 times the mass of oxygen to get your final mass. Okay, does anyone have any questions on the basics of finding mass? Like, does anyone have any questions about how I got these numbers? Okay, before we move to the next topic, I'm going to give you about 10 to 12 minutes on a Classkick assignment. So if you go into Classkick, I'm going to make visible Chapter 10, Part 1. It is a 2-page assignment, but we're only doing one of the pages now, and we'll work on the other one tomorrow. All it is I've given you 5 different chemical formulas. You need to get the masses of each individual part and figure out the total mass. Remember, your answer needs to be recorded to 2 decimal places. I've included the link to the interactive periodic table that most of you have been using. One of the reasons I really like this periodic table is all of the masses are already written to 2 decimal places. Okay, so you don't need to do any thinking, you just need to record them. If you're using the paper periodic table from the room or a different periodic table, it may be written out further, like instead of 32.07, it may say 32.07631, whatever. You need to still round that to 2 decimal places, okay? So you may need to do a little rounding. There is one mass on the periodic table that's not recorded to 2 decimal places on here, and that is hydrogen. Hydrogen, they have written as 1.008, okay? So it is okay to use that if you'd like, or you may round that to 1.01, okay? But don't just write 1 or 1.00, because that will change things significantly. Okay, so go ahead. I'm going to give you